Good afternoon, everyone. Myself, Ritwik Bhaskar. I am here to discuss some key concepts and operations on immutable sets as well as immutable maps. What are the contents that we are going to discuss in this video? We are going to discuss and understand what are immutable sets, exploring what are immutable maps, comparing immutable and immutable data structures. First, under section 1, we are going to understand what are immutable sets and its key benefits. What is the definition and characteristics of immutable sets? Definition of immutable sets. Immutable sets are data structures that cannot be modified after their creation once they are created, ensuring that their elements remain constant after creation throughout their life cycle. A set is permanent after created. It only helps in making copies under every operation. Key characteristics. They support unique elements, meaning no duplicates are allowed, and operations such as union and intersection return new type of sets. Original promoting functional programming principle. Under third category, benefits of immutability. The immutability of these sets leads to easier reasoning about the code behavior, certain contexts due to the structural sharing and reduced side effects. What are the operations on immutable sets? Set creation and initialization, common set operations like union, intersection, and the difference, performance consideration. Under set creation and initialization, immutable sets can be created using specific functions that define their elements, ensuring that once the set is initialized, the set remains unchanged throughout the process, which is crucial for maintaining data integrity. Common set operations. Operations such as union, intersection, and difference are performed by returning new type of sets or copies of the original set, allowing for safe and predictability manipulation of data without changing the original one without side effects. Performance consideration. While immutable sets may incur overhead during creation of new different sets for operations, they often leverage structural sharing to optimize the memory usage and enhance performance in functional programming environments. Now let us discuss about some pros and cons of immutable sets. First, let us discuss about the pros of immutable sets. Enhanced concurrency support, predictability behavior, reduced side effects, structural sharing benefits, easier debugging, and improved memory efficiency. The easier debugging helps a lot because the original set remains unchanged and the new sets are copied. So it helps to make changes in the copies of the immutable sets. Now cons. Higher creation overhead, potential performance hits, increased memory usage for more copies. For every option, a new copy of the original set is make sure. Complexity in large data sets, slower for frequent updates. So for every update, we have to make a copy of the original set. Use cases for immutable set in functional programming. Concurrency and safety, functional transformation, state management. Under concurrency and safety, immutable sets provide thread-safe data structure, allowing multiple threads to read from the same set without risk of data corruption, which is essential in concurrent programming environment. Thread safe provide a safety to the set that is original and initialized in the starting. Functional transformation. They enable functional programming techniques such as map and filter, where transformation returns a new set or a copy based on existing ones, promoting a declarative style of coding that enhances readability and maintainability. The third crucial case for immutable set is state management. In applications like state management in web framework, immutable sets facilitate and helps in predictable state transition by ensuring that previous state remains same or unchanged, thus simplifying the debugging and testing process throughout the lifecycle. Now let us discuss about some of the advantages of using immutable sets. Predictability. The state of set remains constant and can be used for easy debugging. Thread safety. Immutable sets eliminate the need for locks or synchronization, enhancing the safety of the set. Optimized memory usage. Immutable structure can be shared, reducing overall memory overhead. So the memory is optimized. Application in caching. Ideal for k-chain implementation where data consistency is very crucial. Multi-threaded application helps prevent race condition in multi-threaded. Now let us discuss section 2, exploring immutable maps. First, some definitions and characteristics of immutable maps. Definition of immutable map. Immutable maps are data structures that maintain a fixed set of key value pairs, ensuring that once created, their content cannot be altered or changed, which enhances data integrity and consistency in making applications. Some key characters, they allow for efficient retrieval of values based on unique keys, support structural sharing for performance optimization, and provide a functional programming approach by returning new maps for many modification instead of altering the original one. So the copies can be altered for modifications. Benefits of immutability. The immutability of map leads to safer concurrent programming, easier reasoning about the state change, and reduced side effects of the copies, making them particularly useful in functional programming paradigms where predictability is very crucial. Some operations on immutable maps. Creating immutable maps. Immutable maps can be instantaneous using specific functions that define key value pairs, ensuring that once created, the map remains unchanged for the lifecycle, which is vital for maintaining data integrity in application. Common map operations are such as adding, updating, removing key value pairs, and return a new map instead of modifying the original or existing one. Performance consideration. While immutable maps which may incur overhead during the creation of new immutable map for operations, they often utilize structural sharing to optimize memory usage. What are the three major key operations on immutable maps? First one is addition, adding a key value pair resulting in a new copy of a map of original one. Second one is removal, eliminating a key value pair, producing a new map. Third one is update, change the value for a key and create a new map. Performance consideration, understanding the impact of data structure choices. First one, copy overhead. Creating a new data structure for every modification can be very costly. Second one, memory usage. Sharing structure may save memory but can also lead to fragmentation, which may result in less performance. Optimization techniques. Implement strategies to enhance performance in data structures may lead to optimization. Fourth one, persistence data structure. Utilize trees or graph to effectively share unchanged parts of the map. Efficient copy on write. Only perform copies when necessary to improve the performance. Only the things are only performed on the copies of the maps. Now, section 3, comparing mutable and immutable data structures. The key differences between mutable and immutable data structures are the memory management. Mutable structures allow in a place modification, which can lead to more efficient memory usage. A original copy can again be altered again and again, but you cannot retype the original one. The creation of new instance for any changes potentially lead to increase in memory usage, but enhancing safety, and predictability in concurrent environments. Mutable sets are efficient in memory management and immutable sets are less efficient in memory management. But safety is more guaranteed in immutable set, but whereas safety is less guaranteed in mutable sets. Advantages of immutable data structures. Enhanced predictability, improved performance in functional parity. Use cases for immutable data structures are concurrent programming, functional programming, configuration management. Immutable data structures in algorithm. Backtracking algorithms facilitates easy rollback to previous states without altering the original one. Once the original one is created, it makes copies of the altered things one by one. Although the memory is used, but the original one is saved. Dynamic programming prevents inadvertent alteration of states, maintaining the integrity of data during computation. Complex algorithm simplification eliminates side effects, promoting data consistency and simplifying the implementation of complex algorithms into simple one. Comparing immutable and mutable data structures. The features are immutable, mutable. Features we have to discuss here are modifiability. thread safety, and memory usage. For immutable data structures, modifiability is not possible. Thread safety is very high. Memory usage is potentially lower than mutable data structures. But whereas in mutable data structures, modifiability is yes, it can be modified. Thread safety is very low because the original one is modified again and again. Memory usage is very high. It helps in optimizing the memory with using less memory. Thank you.